Hey guys, back again. So if you're just joining me, this is the second video today. I actually had another half an hour kind of free up of my life on a Saturday afternoon. So let's keep plugging away while the ideas are fresh here. But okay, so I have two instances of cursor running, and then one of them is on my test bench. This is the Linux application. So if you have like a Raspberry Pi or something like that, I just have this old desktop PC running. Um, so I'm just asking, let me log into the Streamlit app so I can inspect. So this is Linux. This is Cursor. Hmm. Okay, so like you, let's see, what do we have here? Did you push updates to GitHub? Have this instance where I don't want it to push update to GitHub. I only want it to pull. Okay, so no, this instance I do not. I want this computer right here, just my old Windows computer running Linux, to be testing, pulling Docker images from GitHub container repository. And then I want this Windows computer I'm recording this video on to be kind of like the software engineer. So I'm telling this Linux instance, no pushing, no pushing to GitHub, only pulling from GitHub container repository and testing. And then we inform bugs to another instance of cursor agents that do push to GitHub. Um, let's see. So these things should have been only for data modeling purposes, not app dev. See what it says about that. I keep on like wanting the AI agent to do the data modeling and then update the app. So the joy of vibe coding is like you really have to like make sure that um, this it's like keeping track of your own little minions. Um, the UI are on like code mounts code. Do you want to recreate the package only? I'm just gonna say maybe prompt me in the form a cursor agent uh, something to fix what you modded, and then we will have the next GitHub container push. Okay, so like the neat thing about this is like you can still pull Python code down, and then you can still you can make it your own. So this is kind of what we're wanting to do here. So I'm just gonna say, okay, so hang tight, this will come the next container update latest. Okay, can you design this? Okay, I'm just gonna say this is from another instance of 19 running elsewhere. Bake this into the um, code app 19. I did that. Was curious to maybe put this on Fable's highest thing, but I don't know if I'm gonna do that now. I might just put this on auto mode because this is kind of I've been having like a lot of luck with not burning a lot of tokens somehow on this auto mode and getting good enough results. Okay, and then curious, another feature to also bake in for each mechanical tab. You have Streamlit app with FD plots and analytics. Is it possible to programmatically build a docx report on each um, plot that would contain the haystack data modeling points required and linked to the raw point columns in the CSV files. So docx would contain all 50 fault rules, all fault rules. Fault rules plot. Then the data model points required, and then one's map for each HU system, or for each HVAC system, and for each HVAC system. I'm having some issues where the AI agent doesn't recognize that. I think it should do a better job at recognizing the CSV names and then know that this is a mixing valve on an air handling unit or a mixing air damper or something like that. So I need a way to report back to the humans that we ran these reports, and then you can see the entire data model and then a plot for everything. So, and if there's something not showing up, you can very easily understand why. So I want the plots and docx to show up in the browser for each mechanical tab. The required haystack marker names, whatever to the call names in the data set. And if it does not apply, we would still see just an empty placeholder with the required haystack tags and fault description. Fault description. Also same for analytics. Maybe I will just put this on Fable 5. Okay, then I'm going to ask it to please ensure this agentic AI spec is up to date so that no charts are left undone and nothing is missing. Say we also need a tab for data model to tree out professional looking front end current data model mapping as well, both docx and front end. All right, so have a little bit of time to kill. Let's see if we can make this real quick. I'm just gonna put it in plan. Let's take you off of auto, and why not burn some tokens? Please plan and build this update. All right, full Fable go. So you must acknowledge the data retention policy. Okay, whatever that means. This is getting there to a few places. Is it doing anything or not? I've noticed this before once that I've used Fable like this before, and then it just like sits like it's just like dead in the water for some reason. So we have GPT 5.6. We have Sol. Sol. It's like, is it doing anything? Impatient human. Come on, Sol. Come on, Fable. So I think like if Fable 5 is okay, so it said yes, but the request a plan plus a large build. So I'm in read-only planning first. No code is being changed yet. So okay, so I might put you back to auto mode. So to say like once app can be, I'm gonna say please test the application as well, that there are no errors in the Streamlit front end. Seems like Streamlit provides all the errors in the front end of the HTML. And then let's push new containers to GitHub container repository. I think this will be queued. Super annoying. Okay, so like plans. I feel like I just like bombarded cursor with a whole bunch of stuff here. So let's switch back to the other one because they'll probably be busy for a couple minutes. Get rid of you. This is just my edge instance. So let's do this. Some of this stuff is like just merge it all in. We are only vibe coding here. Don't worry about separate PRs. Updating tests would be nice. Do that. Okay, so I'm talking about unit tests in there. So which wanting to open a couple of GitHub pull requests. A to B on-demand docx not recompute. Okay. We'll try this. So This is going like way slower, even using AI to make some of this stuff. But I think we're getting some places. Hope you guys are having a good summer. Another hot streak coming in the northern hemisphere. Um, Tests right now, unit tests, which is really nice. Okay, so like, let's just get back to.
All right. So another question that I've
Got some new YouTube videos on Hermes. Who knows? I was using a little bit with Codex, which it does look like my Codex did renew here. I think there might even be a Codex desktop tool. Maybe I should use that because the Codex CLI is kind of a pain in the butt. Like it constantly asks to, I just wanted to do things, and it's just like, needs permission to run this command, needs permission to run this command, and it's just like, oh my god, it's kind of ridiculous. Maybe we'll have to look into this, just like creating like a Codex, using the Codex desktop. Okay, so we are looking at these rules online, and I have a feeling like with kind of what we're doing here is might even be adding to some of these rules. So I'm going to keep this open. Is our little cheat sheet for rules? Maybe like what we could do is just look at some of the code here. Put you aside. So this is our Streamlit application. It's running into, it's getting to be a pretty decent size app now. We know all these Python files. We have vibe coded just to make the Streamlit application. Pretty cool. Agent API. So this is like just the API actually that the AI agent can help the human. Then these are like the fault rules. So like what happens behind the scenes is like I iterate over the data model, and it will basically be able to if this rule applies to this air handling unit system or something, that it'll run the rule across the data. So like if there is a variable volume fan, then we can use a duct static pressure rule, and it'll automatically run the rule across the data. Look catalog, 1,000 lines long. The reheat valve stuck. And all Python functions. I think this is turning into 11,000 lines long of fault detection rules. Cool. Anomaly detection. I think there's a ton of creative stuff that we can do in here to find some cool things wrong with HVAC systems. Okay, let's see where our agent is at. Okay, so 246 unit tests, so pretty cool. AI is really good at writing. All right, so wow, it actually shipped the Docker container already. Ooh, okay, so we can give this. This happens all the time where like it shipped all of this stuff and then I'm expecting it to like this is a queued prompt where now it's confused because everything was already shipped. Already on one commit, tightening regression tests. Oh, so it's testing again. Failed test. We should be able to go to GitHub, Python backend stacks playground, and then see GitHub packages for our Vibe 19. Oops. Minutes ago. Okay, so this it did put the latest container up there, and then we're going to ask the Linux desktop computer on the edge right here to pull this container from GitHub, and then run it through its paces. I'm just going to ask for this guy to pull it, and we can just keep on updating. So, latest container and run everything for the 100 building and the weather data set. So let's get this guy munching away on data, pulling the container down. I'm amazed at like how fast this goes with Python. So like Python is not a compiled language. It does compile when it pulls the container down and then it's on the Linux computer and then it compiles it at runtime. But when I do this in Rust, it I push all the code to GitHub and then it has to compile on GitHub Actions. Sometimes for a really long time, like a half an hour. Some of the really big Rust applications, it was a couple of hours, I think. I've seen something go for, but the Python stuff moves really fast because it just pulls files down, the scripting files, and then once it's on the Linux machine, then it compiles at runtime. See if we can spin this up and then test it out. So like what I was really interested in was having something that you can build and ship to the client almost at the same time. Like what I'm imagining in my head is like making charts, running analytics, and then checkbox report add to report, like all at the same time. So that's what I'm hoping for. Um, like I used to do this in retro commissioning. So I've spent most of my career, let's say 10 plus years as a field technician for HVAC controls. And then some of that time in between contracting jobs, I worked for engineering consulting firm doing retro commissioning in the field. So like it wasn't much different than being a field HVAC control system technician. So for retro commissioning, this engineering firm would fly me around the United States, is where I live, and I would recommission old federal laboratories and hospitals, point by point by point. So like I would spend anywhere from 2 weeks to a month, a lot of time in like the Denver Federal Center where they have like federal laboratories and also federal hospitals. So they would be I would get an old laptop or something from the client and then go walking through the building, making sure every valve goes back and forth, every sensor, visually inspect it, and then tally, broken, 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 dampers don't seal effectively, valve is leaking, um, valve doesn't actuate, any of that kind of stuff. You'd be surprised on really old junk out there what does and what doesn't work. Especially federal stuff can be really just old and way outdated. And then I would be have to go make reports of like how the HVAC system operated over time, all in Excel too. So okay, so what do we have here? Okay, so it's where let's dial in. Okay, so Streamlit's running, has its little triathlon guy up there. Still kind of interested to know like what goes behind the scenes in Streamlit, if there's some compiled application running all behind the scenes. So I guess like this is saying incomplete topology loaded. Whatever, that's fine. Okay, so we have these two pieces of equipment, all the VAV boxes for the 100 building. This looks not bad. What do you build us? Red thing is kind of annoying to look at. Data model. Okay, we have 50 rules, 300 polling second air handling unit. I might have to zoom this out a little bit. Okay, that looks good. It's starting and reckoning the ending dates. 2,631 hours of data from here to here, start to finish. I'm going to put these up to 70. I should change this 70 and 75 as the default. In the United States, there's energy code requirements where they have a 5-degree deadband by energy code. So if the mechanical engineer always says to the building needs to operate as code requirements because they're licensed to say how they want the building to operate, but no one ever automates it that way. I never realized way later until 10 years into my building automation programming field technician work that even existed. Everyone knows that there's code requirements for ventilation. That's very common, like ASHRAE 62.1. But some of the energy code requirements, there's a huge disconnect between the engineers that are enforced to write a specification and then the people that actually implementing it for energy code. Ventilation code is pretty well known, but the energy code requirements is like big disconnect. So I think like energy code requirements is ASHRAE 90.1. and ventilation is 62.1. We just got to put this back to our Saturday requirements. Run the numbers there in the scenes. Okay, so what do we have here? So I still might have to change this though. There's a drop downs for equipment, but we may not need that if we have some of these different tabs. Okay, so the bare minimum runtime calculated based on that generic weekly calendar hour is 67 weeks. And then we should have a fault rule running that will have to validate that if the zone temps are satisfied in the building and we're still running the air handling unit longer than that's a fault, and we'll be calculating through analytics, these extra run hours based on if the zone temp is satisfied. We talked about this earlier too, like you can kind of see in the data kind of drops off, which is somewhat typical to shoulder season. That's when we should absolutely be running their air handling unit bare minimum when we're in this 50 to 60 degree outside air temperature range. In theory, you wouldn't need to heat the building, so we only run the air handling unit for ventilation purposes only. And then I guess like the either optimal start algorithm or something is, or the human operators are running equipment longer, more than likely because it gets hot, like right up to the 4th of July is when there was some really hot weather. So we just caught the tail end of that. And then at the beginning of this data set, we caught the tail end of the winter. So we have this really beautiful spring capture. We caught the complete end of heating season all the way to the beginning of extreme mechanical cooling season. So that's really good for retro commissioning projects in general. Is like really good projects that I've seen are a year long, and we capture a completed heating season. So that would be fall economizer season to spring economizer season, capturing that full window and heating performance, focusing on the boiler system. And we shouldn't be economizing the air handling units all winter long, causing excess reheat energy wasted if it's a VAV system with reheats. And then we, so heating season, economizing season, and peak mechanical cooling season. 3 really important. And there's 2 shoulder seasons, obviously. So I'm dying to know where this will be in our DocX report, though. Boiler system, like we talked about, they're not doing any reheat in the building, so that could be a cause of concern. Chiller plant. So this is mechanical cooling hours recorded, which makes sense as you could see the general trend in the outside air temperature averaging is higher. And then you kind of see the general trend that there's mechanical cooling, hours of mechanical cooling happening with a chiller. And it's just so odd that when it's 0 degrees outside, less than 20 degrees Fahrenheit, that the chiller is running in the building. Why that is, I have no idea. But so this, this is outside air temp here. So it actually did capture in March 60. Okay, so that does make sense. That's why. But just beginning of the this is different. I need to notice this. This is different access over here. So so in theory, we could be trying to shave off a little bit there. Binning outside air of mechanical cooling. So this is like when it's 45 degrees to 50 degrees outside, we shouldn't be running the chiller at all. Neither here, but we recorded 36 hours of mechanical cooling runtime. Ideally, you would want to try and economize up to 60 degrees. So we've talked about this before. Like there is 100 and 120, 100.25 hours of chiller runtime plus 36 plus so like 130, 138 hours or so of mechanical cooling runtime that we could have been not running the chiller, perhaps. So like that's direct energy impact on the owner's bill. Okay, where else can we go with this? So this is this looks normal, normally distributed chart. Most of the data is in between this range. Shoulder season. Some of this can exist too because the difference in the outside air temp sensor to the building's actual hardwired sensor. So this deviation here, like if the I think we saw in the previous videos that the charts were almost 5 degrees off at time. So this is made from the data from the web. Web weather made this, and what could cause this is because the local outside air temp sensor, which enables mechanical cooling to run if the outside air temperature is above 55, if it's off by 5 degrees, it's causing it to run too soon, when in theory you shouldn't need it. Okay, so you can download that as a bin. All right, so you can download this. You got some cool buttons here to download things. Plotly, you can take the charts. You can take a snip that'll download a plot of that. All right, so where is, the only thing I'm not seeing is our docx feature. Okay, so data model and mapping. Let's see what this one does. Streamlit's pumping away up here. Okay, so this is the data model. Let's see what you have for the data model. Okay, so these are the fault detection rules. So I have to mull this over a little bit. These are the different rules that we have in a cookbook. Looks about right. So if you remember, this was a, let's just look at this for a second. I just have to find it. And then I feel like I am already out of time today again. Okay, so let's see, where were we? So I have to just find this in my desktop environment. Second. A different place I can find it. I might have accidentally deleted it. Some of these snips. We've looked at these on a couple other videos. So air handling unit. Air handling units look like this. So we have chilled water valve. We can do leaking chilled water fault, mixed air temp sensor, space temp sensor, return air temp sensor, leaving air temp sensor, and building pressure and duct static pressure. So pretty common little variable volume air handling unit here. reach supply and return fan. Discharge air reset set point 50 degrees. Now that is kind of cold. Why are they discharging that low? So it almost seems to me, just my guess is that I think this building might have aged mechanicals. This graphic looks like out of the early 2000s, so the control system is old. And I'll see if I can even get permission to the um, the building owner has a 3D mechanical room mapped out, so you can actually walk through the mechanical room. Like if you're walking, you can look at the valves and the variable frequency drives and everything like that, which is really cool. So I'll see if I can get permission to actually show that on YouTube. And yeah, this is usually 50 degrees Fahrenheit. It's really cold. Um, we don't usually drill that cold unless there's some zone in the building that is not keeping up. So what do we have here? So we don't have chilled water, leaving temps, cooling valve. Yep, we do have that. So that's present, yes. Ductstatic pressure set point, left hand, yes. We don't have heating control. Okay, so this does look good. No, no, no. We can't do that. PID hunting. Ooh, we should be able to do this. I'm gonna tell it needs to do PID hunting. Mixer temp, so those rules apply. Some of this stuff looks kind of odd. Why it has different names. To dive into that a little bit. Return air temp sensor, so that looks good. So it doesn't have this trim and respawn stuff. Maybe we can look at that later. And it does have one zone temp sensor mapped to it. Okay, so I think this is it's getting a little better. Getting a little better, guys. So I still don't see a good way to um, export the let's see, is it running? So I still don't see a good way to export in the Word document. Applicable rules for this device. Okay, I've got the triathlon guy going up there in the corner. Standard mean deviation. Okay, so yeah, let's start looking into this. Let's just try this. So, okay, so it did have this. Build the fault detection docx for this device. See a few things look kind of funny for this. See what it does. I think tomorrow I will have to vibe code this a little bit just to get it looking better. Triathlon guys going nuts up there. Let's see. So can we full screen? This is all of the zone temperatures plotted. Okay, so I think I'm gonna have to close this out a little bit. All right, so let's just see if we have a export. Let's just download some of this stuff. The only thing that I see that looks like kind of crappy is there's no way to download the data like the docx. Like it's not quite what I imagined, but I think we can get it there. So Fable 5 kind of failed. Yeah, something's not right. Okay, anyways, I think we'll get there, guys. All right. Here is the looks like we could download the docx. Maybe I can go to Google Drive and just throw it on there real quick. See what it looks like. What do we get? I think we're just gonna have to keep pushing it. So anyways, we're getting there, guys. So I'll be jumping on this in the morning, and I will see you guys later. Got a little bit of work to do here, so before we get something cool. Hope you're having a good one, and see you tomorrow.